Hi, in this video I would like to give you an example to use Monte Carlo simulation for pricing the look-back call option, and we will again use antithetic variance technique, which is one of the basically simple variance deduction technique. And in this look-back call option, basically the payoff is based on the maximum of the stock price over, let's say, certain number of monitoring dates or times. And again, once you calculate the maximum, the rest is just like the regular call option. So you have S max minus the strike, and you take the maximum with 0. So this is quite similar to the regular call option pricing, and you can see first I just input some parameters for my option pricing problem, like this is the number of monitoring dates, and basically the number of time steps. Here I'm using M, but that's just the same. So as 0 initial stock price, the strike price, we have the time to maturity, risk-free rate, volatility, and so on. So the discount factor is calculated here. For each time step, we have the delta t is given here. And the first for loop, you can have this or you don't, you can ignore this, both is fine. And I just want to change the number of Monte Carlo samples in an increasing manner so that we can at the end plot the evolution of the estimated prices with different sample sizes. Okay, so if you want to make such a plot, you can have this for loop, but otherwise you can ignore that. And basically the rest, here we are generating all the necessary standard normals at once. And since we want to also use the antithetic variance method, which is a variance reduction technique, remember we include this minus z term so that our sample of standard normals is perfectly symmetric. Okay, and just be careful here. We need to double the sample size by 2 times n now, since we combine these two like z and minus z together in a single matrix of standard normals. So anyway, then the rest is almost the same as just like any other Monte Carlo simulation for the call option or other types of option pricing problems. So you can see that I'm taking the maximum of my stock price path over these m steps, and my payoff is calculated here as a increasing sum. And at the end, once I finish this for loop, I am calculating the average discounted payoff, which is my estimate for the look back option price. And as I said, if you want to create such a figure, you can include this, and you can see how does the Monte Carlo antithetic variate estimators give the results over increasing number of sample sizes. So if you run this, you can see different shapes. So every time I run, I'm gonna get some different result because I didn't fix my random numbers, but you can use the MATLAB's built-in function to do that. But actually, as you can see, we can see, I mean, if we increase our sample size much more, maybe not 5,000, but like, for example, 5 million, I mean, if you run the simulation, then that's going to be, of course, much more accurate since I'm using really small samples here. Okay, so actually you need to use much larger sample size to get higher accuracy.